In some questions, you will see that they will ask you for maximum minimum displacement or velocity. So what is the concept behind that? For this, we have to think back to our application of differentiation, whereby if we want the maximum or minimum value of y, so just basically any turning points, your maximum and minimum value are your turning points. So if you want to find that of y, you'll basically differentiate y to get your dy dx and let it equate to 0. So similarly, to get your maximum minimum value of s, you'll differentiate s, so ds over dt, and let it equate to 0. And then for v, you'll just differentiate v, so dv over dt, and let it equate to 0. After you equate it to 0, you will realize that you'll be solving for t, so the time at which your s of v is stationary. But if the question specifies your maximum minimum value of s of v, you need to substitute this value of t back into the expression to get what we actually want. So let's say your expression for ds dt or dv dt is a quadratic expression, so there will be a t square in it. If there's a t square in your expression, then you'll realize that you will end up with more than one values of t, for which s of v is stationary. Then you need to figure out which value of t gives you the maximum or minimum point that you want. Therefore, you will need to use the second derivative test to determine which value gives you the maximum or minimum. So maximum, you should be looking for d2y dx square is less than 0. But for minimum, you should be looking at d2y dx square, which is more than 0. Now this is just an example using y. So if you are finding for s, then it will be d2s over dt squared. Then if you are finding for v, it will be d2v over dt squared. Now let's see some examples. So in 16.2 II, a particle moves in a straight line so that t seconds after leaving a fixed point O, its velocity is given by this expression. So you'll see now we have trigo in the expression, so we have to think a bit of our trigo concepts also. Firstly, find the time at which the particle first has a velocity of 4 meters per second. So very easy, this one they're just telling you that v equals to 4. So you just let this expression equals to 4. Then afterwards, you divide both sides by 6 to get 2 over 3. Then you will find your basic angle first by just doing a sine inverse of 2 over 3. Your basic angle is just your angle that is less than 90. So if you get this basic angle, there are two possible quadrants that your t can be in. Since your 2 over 3 is a positive value, that means it must be in A, first quadrant, or S, your second quadrant, because this is sine. So in the second quadrant, S is your second quadrant, so first quadrant, second quadrant will both give you a positive value. Therefore, you'll end up with 1 over 3t. This 1 over 3 comes from the angle in your sine expression. So 1 over 3t will be equals to your 0.72973. This is in your first quadrant. Then you need to find the angle in the second quadrant. So second quadrant, you always use pi minus your basic angle. So pi minus this one. And then afterwards, after you get your values, you need to times 3 throughout to get your t, because now you have 1 over 3t. So then you'll get your t as 2.19 seconds and 7.24 seconds. Your 7.24 seconds will be rejected because the question is asking for time at which the particle first has a velocity of 4 meters per second. So it must be the first occurrence. That's why you will choose the shorter timing, which is 2.19 seconds. Now part 2. Find the initial acceleration of the particle. So initial, you will naturally have to think of t equals to 0. Then to get your acceleration, you will have to differentiate your v. So from here to here, it's just your differentiator of your v. So differentiating trigo, sine gives you cosine. Then you need to multiply it by the differentiator of the angle. So 1 over 3. That's how you get 2 cosine 1 over 3 t. Then afterwards, we'll sub our t equals to 0 inside. So we sub t equals to 0. Cosine 0 will just give you 1. That's why you'll end up with 2 meters per second square. Part 3. Find an expression in terms of t for the displacement of the particle from O. So displacement is your s. And right now, you have your v expression. So in order to get s from v, you will integrate v with respect to dt. So you will integrate 6 sine 1/3 t dt. Integrate sine, you will get negative cosine. And then you have to multiply it by the reciprocal of the angle. So 1 over 1/3. That will give you 10 times 6, the constant here, it will give you negative 18. Cosine 1/3 t, remember your plus c. And now you need to find what your c is. So looking back to the question, they tell you that t seconds after leaving a fixed point O. This is to show you that when t equals to 0, s equals to 0. Because the time only starts counting when you pass by your fixed point O, which is where s equals to 0. So you sub t equals to 0, s equals to 0 to get your c as 18. So finally you sub your 18 back into your c and you'll get your final expression for s. Last part, the maximum displacement of the particle from point O. Now for this one, even though they're asking you for maximum displacement, you don't have to do the differentiating and then let it equals to 0 and then find t, all this. Since it's trigo, we can think back to our maximum and minimum values of our trigo curves. So we'll start with cosine. Cosine 1/3 t is between the range of negative 1 and 1 inclusive. Then you have to times everything by negative 18. So negative 18, and then afterwards you have to add your 18. So this forms back your s. So minus 18 plus 18 equals to 0. And then 18 plus 18 gives you 36. So this will be your maximum displacement of 36 meters. That's how you'll get this answer. A particle travels in a straight line from a fixed point O, where the distance s in meters is given by this expression, where t is the time in seconds after passing O. So this will tell us when t equals to 0, s equals to 0. So we have k and q as constants. The velocity of the particle is 20 meters per second when it passes O. So this line tells us that when t equals to 0, v equals to 20. And at t equals to 3 seconds, its acceleration is 0. So at t equals to 3, a equals to 0. Firstly, find the value of k and of q. So the information that we have now is in terms of v and a, but the expression we have is in terms of s. So we first need to do our differentiation to get our v from our s expression. So v equals to ds over dt. So here we'll differentiate our s expression to get our v expression. So differentiate, we'll just bring down this power, reduce the power by 1. That's how we get 4t squared. Same here, bring down the power, reduce the power by 1, so 2kt. Then for qt, we're just removing the t to leave us with q. Then from the hints that we have in our question, t equals to 0, v equals to 20. We'll sub this in to our v expression. So we'll sub this in here. Then we'll solve for q and we'll get q equals to 20. Afterwards, we need to differentiate v one more time to get our a, because our other hint is in terms of a. So a equals to dv dt. That's why we'll differentiate this one more time to get our a. So reduce the power, bring down the power, reduce the power by 1, you get 8t. Then for 2kt differentiated is just 2k. That's why you get a equals to 8t plus 2k. Then the hint that we get from our question is that when t equals to 3, a equals to 0. So we will sub this in into our a expression. Then we will solve for k, and k is just equals to -12. So we have q equals to 20 and k equals to -12. Part 2. Find the values of t when the particle is instantaneously at rest. So here we can identify that the question is asking us to find when v equals to 0. So we'll sub v equals to 0 and we'll get 4t squared minus 24t plus 20 equals to 0. Then from here we can factorize 4 out. Then we'll just get t squared minus 6t plus 5 equals to 0 by dividing 4 on both sides. So you'll just get rid of this 4. Then you'll do our simple factorization, t squared plus 5 negative 6t then we'll have t minus 1, t minus 5 equals to 0. To solve, we'll get t equals to 1 or t equals to 5. So these are your two values. Finally, find the total distance traveled during the first 8 seconds. So like the previous question, first we always check if the particle starts at fixed point O. So in this case it does, because here it says t is time in seconds after passing O. So t equals to 0, s equals to 0. Then we need to find the displacements at different points, like in the previous questions. First, you need to find it at the start, so at t equals to 0. Then you need to find it at the turning points. So turning points is where your particle is instantaneously at rest. We found it in part 2 is where t equals to 1 and t equals to 5. Finally, it is our endpoint. So endpoint in the question is 8 seconds. So therefore, we have to find at t equals to 8. Now we'll just sub all these values, all these t values into the expression of s given in our question here. Then we'll get all these respective values of s. Now we can draw out our particle path to help us determine the distance traveled. So we'll start at t equals to 0. So our fixed point O is here. So here is where t equals to 0 and s equals to 0. So our particle starts here, then it starts moving up till our first turning point. So here is where t equals to 1. The distance, or rather our displacement when t equals to 1 is 9 and 1/3. Therefore this is 9 and 1/3. Afterwards, we need to account for our change in direction, so we'll be turning backwards. Then we'll look at our next turning point at t equals to 5. S equals to -33 and 1/3. So negative means that we have gone past the initial point, fixed point O. So we'll go back. It will stop around here. This is our t equals to 5. Once again, this distance here is with respect to our fixed point O. So it's not this entire distance. That's not correct. It's actually from our fixed point O. So this distance over here, then is our 33 and 1/3. So now we need to go all the way until the end. So we will move past fixed point O again and go all the way until our t equals to 8, so our final point. Looking back to our value, it is 74 and 2/3. So this is once again with respect to our fixed point O. So here is our 78 or 74 and 2/3. Now to calculate your total distance, you are calculating this. So your first 9 and 1/3. Then since you turn around, you have to encounter for this. This is your second 9 and 1/3. Then you continue moving to t equals to 5. This is your first 33 and 1/3. After you pass t equals to 5, you will turn back. Turn back to reach your fixed point O. That's another 33 and 1/3. Then you will just complete the rest of your journey, which is your 74 and 2/3. So it's here. So if we label properly, this length will be 9 and 1/3. This length will be 33 and 1/3. So you just add them all together to get 160 meters. Okay, last example. Our particle P travels in a straight line so that our velocity at time t seconds is given by this expression. The particle first crosses fixed point O at t equals to 1.5 seconds. So what this line tells us is that at t equals to 1.5, our s equals to 0 because it just crosses our fixed point O. Firstly, find the acceleration of particle at t equals to 4 seconds. So we have v, we want to get a. To do so, we have to differentiate our v. That's how we differentiate this expression we have to get our a acceleration expression, 2t minus 5. And then we will sub in t equals to 4 seconds into the expression, and we will get 3 meters per second squared. Part 2. Find the time interval during which the particle's velocity is decreasing. So we'll think back to the concept of, to find when a function y is decreasing, you will think of doing dy dx less than 0. So with the similar concept, with our velocity, to find when our velocity is decreasing, you take dv dt less than 0. This is your acceleration. So that's why here, your acceleration is less than 0. Then 2t minus 5 is less than 0. You shift the 5 over, divide by 2 on both sides. You should get this answer at first. However, you cannot have a negative time. Therefore, there will also be a boundary whereby your t is more than 0. That's how you end up with t being in between 0 and 5 over 2. So here, please change it to t is more than 0. Part 3. Find the displacement, so your s, of the particle from O when it's first instantaneously at rest. Instantaneously at rest, you will think of velocity equals to 0. So you will let your v equals to 0. Then you will just do your factorization of your t squared minus 5t plus 6. It will give you t equals to 2 or t equals to 3. Then look back to the question, what do they want you to find? Your displacement. To get your displacement from your velocity, you will have to integrate your velocity. That's why you will do your integration and you will get this expression for your displacement. So then you will see here you have your constant of c. You need to find this c. That's when you think back to what the question told you. The particle first crosses fixed point O at t equals to 1.5 seconds. So you think of this. So you sub t equals to 1.5, s equals to 0. You sub it in to your s expression to find your c, which is your negative 4.5. So between t equals to 2 and t equals to 3, we'll be choosing to sub in t equals to 2 because the question specifies when it's first instantaneously at rest. So t equals to 2, obviously we'll reach t equals to 2 first instead of t equals to 3. Therefore from here, we have our s expression, t cubed over 3 minus 5t squared over 2 plus 6t minus 4.5. Then we will sub t equals to 2. When you calculate it out, your s will be equals to 1 over 6. So therefore, the displacement of your particle from O when it's first instantaneously at rest is 1 over 6 meters. Part 4. Find the average speed of the particle for the first 3 seconds. So in order to get your average speed, you need your total distance over total time. The total time is given, here is 3 seconds, given in the question. Now we need to find our total distance. So once again, you need to find 3 different displacements. 1, when it starts, so where t equals to 0. Secondly, when there's a turning point, so a change in direction. That's when your t equals to 2, t equals to 3, as found in your previous part. Third is your end point. In this case, since it's 3 seconds, it's also t equals to 3. So you'll sub in your respective values of t into your s, and you will get s equals to minus 4.5, s equals to 1 over 6, and s equals to 0. So now we can map out our path. So we'll start off with our fixed point O. When t equals to 0, s equals to negative 4.5, means our particle is 4.5 meters behind our fixed point O. So this is where t equals to 0. And here is your 4.5 meters. Afterwards, you will go forward until your first change in direction at t equals to 2. Here is your 1.6 meters that you found here. Then you will continue traveling all the way to t equals to 3. T equals to 3 is 0 meters displacement. Therefore, it goes back to your original point of O. So if you label properly here, here is also 1.6 meters. Therefore, your total distance is 4.5 meters plus 1.6 meters plus another 1.6 meters, so times 2. So that's your total distance. Then to find the average speed, you divide it by your total time given in the question is 3 seconds. So you'll get your answer of 1.61 meters per second.